starting lesson 1-3, average rate of change. Okay, you, since algebra, have heard the term average rate of change. What does that mean? Slope. Okay, so we all know the slope formula. What is it? That right there. Okay, so we usually use m for the variables. So slope is y2 minus y1 over x2 minus x1, where both of these can't be the same number because then that gives us a slope that's undefined. Okay, so the average rate of change of y with respect to x as x changes from x1 to x2 is the ratio, anytime you hear ratio, think fraction, of the change in output to the change in input. Sometimes for change in output, we call this delta y over delta x. So change in y over change in x. Remember when you first started learning about functions, they called x the input, and then you plug it into this machine, and you do whatever the function tells you, and it cranks out a number, and that's called the output. So that you may not remember, but that's probably the first way you started talking about functions. So output, they just mean the y value, input the x value. Okay, so this is our slope formula. That we have been using for a while. Okay, but wow, this does not look like slope formula here, does it? Okay, so take a look at this. If we look at a graph of the function, this is just some generic function here, we see that y2 minus y1 over x2 minus x1 is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, which is both the average rate of change and the slope of the line from point P to point Q. The line through P and Q, or PQ, is called a secant line. Okay, that is a whole lot of stuff packed into this. Okay, so let's see what's going on here. All right, so I have some piece of a graph. Looks like maybe a piece of a parabola, right? All right, so I have this point P, and I have this point Q. Okay, notice that they are not using numbers here. They're just using generic, okay, this is x sub 1, and then this is x sub 2, which just tells me, hey, these are different x values, where x2 is bigger than x1. All right, then the y values are also generic too. This is y1 and y2. Okay, but think about this. If I had a function, let's just say it's x squared, and I wanted you to plug in 2, then I would say find f of 2, right? And if I plugged in 2 and squared it and I got 4, then I would say f of 2 is 4. Okay, so the y value is f of that x number. So if you look over here, it also is calling the y value f of x1. So it means you took x1 and you plugged it into the function, and whatever you got, that's your y value. So that's what that fancy notation means. This says f of x sub 2. It means you took... Is there music? Is it mine? Above us? Let's close the door, see if it helps.
Now that I turn my ear, it's definitely there. I see it. Really? Once I turn my head, I can hear it. For sure.
It was like it's deflecting off that wall or something. I thought it was coming from up here.
That's what I was saying.
Sorry about that interruption, Jesse. Y'all think he's going to watch this? No. Jesse, did you hear that? Okay, so for this x value, x sub 2, I'm going to sub it into the function, which means find f of x2, and then what I get is the second y value, so it's also called y2. So all that fancy notation just means you've plugged this into the function and you got that y value. Okay, so what is a secant line? Do you remember from geometry that a secant line is a line that intersects something more than once? Okay, so that secant line is intersecting that function in 2 points, and those 2 points are P and Q. Okay, so all this little blurb over here is saying is that if I took these two ordered pairs and I found my slope formula, y2 minus y1 over x2 minus x1, which could also be written like this: plug x2 into the function, that's what you get for your y. Plug x1 into the function, that's what you get for that y. Subtract them, and then subtract the x's in the denominator. That's just your slope formula. Okay, but that slope formula between these 2 points is also the slope of this whole line. So it's the slope of the segment, but it's also the slope of the line. Okay, so not too advanced, just written in a very fancy way. Is everybody okay with that? Next. Okay, so for y equals f of x equals x squared, find the average rate of change, aka slope, as x changes from 1 to 3, as x changes from 1 to 2, as x changes from 2 to 3. Okay, so let's picture this graph. That's just a plain old vanilla parabola, right? Okay, I would go ahead, and these x values that were given, let's just go ahead and find the whole ordered pair for them. Okay, so x is starting at 1, and then it's going to 3. So let's just find the ordered pairs on the function. Okay, well, if I sub 1 into x squared, 1 squared is 1. That's just telling me there's a point 1, 1 on that graph. If x is 3, sub it in, square it, I get the ordered pair 3, 9. So if I want to find the average rate of change as x changes from 1 to 3, it's just saying find the slope between these 2 points. So let's use our slope formula. I'm just going to set up A right here. So the slope will be y2 minus y1 over x2 minus x1, which is 8 over 2, or 4. Okay, does it make sense that if I connect these 2 points, I would have a positive slope? Yeah, especially knowing what this parabola looks like. 3, 9 is going to be way up here somewhere. Yes, if I connect those, that should be a positive slope. Okay, next part, B. Find the rate of change, aka slope, from x equaling 1 to x equaling 2. Well, we already know that order pair 1, 1. But what about the order pair 2 something? Okay, well, let's sub 2 into the function, square it, and we get 4. Now use your slope formula for this. So m equals y2 minus y1 over x2 minus x1. So I get 3 over 1, or 3. So that segment between those 2 points would be less steep than this one. Makes sense, because 2, 4 is closer on this parabola to the initial point 1, 1. All right, then part C, same thing, but now we're going from x equals 2 to x equals 3. We already have both of those ordered pairs. When x is 2, our ordered pair is 2, 4. When x is 3, our ordered pair is 3, 9. And I'm going to find the slope between those. So 9 minus 4 over 3 minus 2 is 5 over 1, or 5. So that was the steepest one of all of them. Question on that? Okay. State the average rate of change for each situation in a short sentence. Be sure to include units. It rained 4 inches over a period of 8 hours. What the heck? This isn't a function. I'm not plugging in an ordered pair. I'm not using slope formula. What is this talking about? Find the average rate of change. What's changing? What's changing here? It rained 4 inches over a period of 8 hours. The rain over a period of time. Okay, so would you normally say it rained 2 inches each hour, or would you say it was 2 hours per half inch of rain? You'd say the first way probably, right? How many inches of rain per hour? Okay, so our statement is just going to be not an equation, just a fraction really. So it rained 4 inches over a period of time. I'm not putting it over it because it has the word over, but think of it as per 8 hours. Okay, so can that be reduced? Yeah, to 1/2, right? So I could say it rained a 1/2 inch per hour. Now, does that mean it's going to rain a 1/2 inch per hour all day long? No, just over this 8-hour span. Does that mean it rained a 1/2 inch each hour? Now listen to this question. Does that mean that it rained a 1/2 inch each hour? It was the average, right? It could have been the bulk of the rain in the very last hour. Or it could have been a steady 1/2 inch of rain over the span of 8 hours. That average doesn't mean that happened each hour. It's just the average over that span of time. Okay? All right, your car travels 250 miles on 20 gallons of gas. Okay, so we're talking about miles compared to gallons. So we can go 250 miles per, always think of per as divided by, 20 gallons of gas. Is that good gas mileage?
Yeah.
Let's see what we get, because let's reduce it. What does 250 over 20 reduce to? 12.5 miles per gallon. I don't think that's too great. I mean, maybe if you were in a truck or a big vehicle, my sporty little Toyota gets better than that. I have a Highlander. I wouldn't call it sporty, but I do like it. Question on that one? Okay. At 2 p.m., the temperature was 82 degrees. At 5 p.m., the temperature was 76 degrees. What kind of rate of change are we talking about here? Change in temperature over time. Okay, so let's think of that y2 minus y1. So let's take the ending temperature minus the beginning temperature over the ending time minus beginning time. So that y2 minus y1, x2 minus x1 concept. Okay, so that's going to give me a negative, isn't it? Negative 6 degrees over 3, and this was hours that we were subtracting down there because it was time. Okay, so that would reduce to negative 2 degrees per hour. Why is it negative? Yeah, the temperature was falling. Okay. 76 degrees sounds amazing right now, doesn't it? And not foggy, not slushy, but misty. Bleh. Okay, question? When are we getting snow? That's what I want to know. Huh? We used to get like, I don't know, one at least every couple of years, but we've not had any in a while here. Okay, let's just do C. Here's your function, f of x equals x cubed. We want to find the average rate of change between 1 and 1.2. Okay, so what do I need to find? The ordered pair 1 something and 1.2 something. Okay, subbing in 1's easy. What do you get? Okay, sub in 1.2 for me. What'd you get? 1.728. Okay, now use your slope formula. Check up here when you get an answer. Everybody good? Okay, so this picture looks a lot like the last one, doesn't it? Got a few more variables on there. Okay, I'm not even going to read this yet. Okay, let's just focus on the picture first. Okay, so I have this ordered pair right here, and the coordinates are x, f of x. Isn't that what we did up here to find this ordered pair? When we needed to find the y value, we found f of 1.2. So you plug 1.2 into the function, that gives you the y. Okay, so that's why this ordered pair is x comma f of x. All right, I traveled down the graph just a little bit. How far I'm traveling, I'm going to call h. So I start at x, and then I travel this way a little bit further. I go down the axis h units, and then voila, I get to this point that's called x plus h. Or that's the same as my second x coordinate, x sub 2. Okay, so if I take x plus h, and I want to find the y value, I'm going to sub this into the function. Just like we subbed this number into the function to get that. So whatever x plus h is, I'm subbing it into the function, and I get this for the y, f of x plus h. Have we done that before? Found an f of x plus h? We haven't. It's been a little bit, but yes, we have seen that notation before. Okay, so the x coordinate is x plus h, and then the y coordinate is whatever I get when I sub x plus h into the function. Okay, so if I think of connecting this right triangle, this distance here is h. This distance here would be this y value minus this y value. So that's why it says f of x plus h subtract f of x. Okay, but what I'm really interested in is the slope here. So the slope between those 2 points. Okay, what's our slope formula? y2 minus y1 over x2 minus x1. So I'm going to set up my slope down here. y2 is f of x plus h minus y1 is f of x over x2 is x plus this weird little h amount that I went down the axis, minus x1 is just x. Okay, well that denominator actually simplifies a little bit because I have an x and then I'm going to subtract an x. So those will actually cancel out. And I could leave this as f of x plus h minus f of x over just h. Okay, it's a whole bunch of letters, a whole bunch of variables, but is that concept okay with you? Okay, so now let's go back and read all this stuff. Okay, so definition. The average rate of change of a function with respect to x is also called the difference quotient. Difference quotient means average rate of change. It is given by, oh, look at that. We just came up with that. That was our generic formula for the slope. So it's just a fancy, super fancy way of writing a generic slope formula where h is not 0. Okay, the difference quotient is equal to the slope of the secant line from those 2 ordered pairs that we had. Okay? Difference quotient means do this. Okay? And we're going to do that on the next page. Okay, for f of x equals x squared, find the difference quotient when x is 5 and h is 3. Okay, let's write at the top here what that difference quotient said. It said f of x plus h minus f of x over h. So we're going to treat that like a formula. We just derived that formula. Now we're just going to use the formula. Okay, so here's our x, here's our h. Let's plug all this in. And here's the function, of course. Okay, so when I find f of x plus h, this means f of 5 plus 3. I'm plugging in x and I'm plugging in h. Minus f of x, that means f of 5. Over h, which is 3. Okay, so let's keep going. That means f of 8 minus f of 5 over 3. Okay, well, how do I find f of 8? I go to the function, sub in 8, I get 64. How do I find f of 5? Go to the function, plug in 5, I get 25, and I'm going to divide all that by 3. Any questions on the setup there? Are you sure? Let's see what we get then. 13. Question. Okay, let's go to B. Same exact directions, but now h is this tiny little number 0.1. Okay, so f of 5 plus 0.1 minus f of 5 over 0.1. Okay, so we're going to keep simplifying. This means f of 5.1 minus f of 5 over 0.1. Okay, now I know f of 5 is 25, but I don't know what 5.1 squared is. 26.01.
Students helping with the 8th grade tour report to the Fine Arts Center. Students helping with the 8th grade tour report to the Fine Arts Center.
Did you get 10.1? Okay. Any questions there? Okay, so this next one is a little more complicated because we're not subbing in any numbers. We're just finding this difference quotient for f of x equals x cubed. Okay, so no numbers being plugged in. We're going to leave it f of x plus h minus f of x over h. So when I say, when I said find f of 5.1, I took 5.1 and I plugged it in the function. If I say find f of x plus h, it means plug x plus h into this function, which means I'm going to cube x plus h. Minus f of x. That's f of x, x cubed. And divide by h. Is everybody okay with that step right there? That's probably the biggest place that people will make mistakes, is just setting up that first step. Okay, what does x plus h cubed mean? It means we are multiplying 3 of these boogers. Then we're subtracting x cubed, and then we're going to divide it all by h. X plus h cubed means multiply 3 of them. Okay, how do I multiply 3? Well, I start with 2 of them. Okay, so let's distribute the first 2. I get x squared plus xh, or hx, doesn't matter how you write that, plus h squared. Then I have a third one to multiply by. Everybody okay with that? Okay, we could simplify this. That's 2 of those. X squared plus 2xh plus h squared times x plus h, barely enough room, minus x cubed over h. Okay, so how do I distribute that? Well, I've got to distribute this to both, this to both, and that to both. So I have 6 things to multiply. Okay, so x squared times x is x cubed. X squared times h is x squared h. Okay, I'm going to move to the 2xh. Times another x is 2x squared h. Then this times h is 2xh squared. Okay, now distribute the h squared. H squared times x is h squared x, or xh squared. H squared times h is h cubed. And then don't forget your minus x cubed, all over h. Not hard, but definitely messy. Okay, we do have some like terms. I see this x cubed. I can get rid of that. Okay, do I have any other x squared h's? Yes, right next door. So that's 1 of those plus 2 of those is 3 of those. Okay, so I've got that one and I got that one. Now these are like terms. I have 2xh squared plus 1xh squared is 3xh squared. Got that one, got that one. Now I have the h cubed, and all that is over h. Any questions? Do you notice that everything in the numerator has an h in it? Okay, so I can factor out an h. 3x squared plus 3xh plus h squared all over h. Now I have a common factor that cancels, and I am just left with this crazy thing. 3x squared plus 3xh plus h squared. And that is called the difference quotient. Now, we are going to do something with these. There is a reason for the madness, but right now we're just practicing crunching through all that. There's a lot of places to make a dumb mistake.
Yes.
Especially when you get like an x cubed. Okay, so this says now use the result that we got to calculate the slope of the secant line, average rate of change, for these values right here. All right, we're just going to do one of them. Let's just do the first one there, so that we don't run out of time. Okay, so let's copy down our formula that we had. 3x squared plus 3xh plus h squared. And then let's plug in the x and the h. So I'll have 3 times 2 squared plus 3 times 2 times 0.1 plus 0.1 squared. And let's crunch that through our calculator. Everybody good? Okay, so if we did the others, then nothing would change except the value of h that we plugged in. Okay? All right, so let's do this one down here. For f of x equals 3 over x, find a simplified form of the difference quotient. Okay, so let's write down this thing here. That's our formula for difference quotient. So f of x plus h minus f of x all over h. That's what we want to do. But this is our function. Okay, so if I said find f of 4, you would plug in 4. If I said f of 0, you'd plug in 0, it would be undefined. If I said find f of x plus h, then I'm going to plug x plus h right there. So f of x plus h is 3 over x plus h. Subtract f of x. That's f of x. Subtract f of x over h. Okay, so this right here is f of x plus h minus f of x. Now, simplify. Well, it's a little tricky. In order to subtract fractions, what do we have to have? Common denominators. Okay, the common denominator here just needs to be both of these things. So this fraction here is going to get multiplied by x over x. This fraction over here will be multiplied by x plus h over x plus h. So I'm just multiplying each by the other denominator. Okay, so when I multiply by these, we multiply top and bottom because I need to multiply by 1. So that's a form of 1, that's a form of 1. I'm not changing the value. And when I multiply fractions, we go straight across. So that's 3 times x over x squared. Let's not even distribute yet. I might in a minute. I'll see. I'm just going to write it like that for now. Minus, distribute up here, 3x plus 3h over x times x plus h, and all of that is over h. Okay, so I have common denominators. Now I can combine them into one fraction. Don't forget that this minus applies to both of these terms. So what is 3x minus 3x? 0. But then I have this minus 3h. So I end up with negative 3h over x plus h over h. And I'm going to think of that as h over 1. Okay, so I'm going to do a little keep, change, flip, multiply this by that reciprocal. So I have negative 3h over x plus h times 1 over h. These h's will cancel. It's a common factor top to bottom. And what I have left is negative 3 times 1, which is negative 3. And then this, I guess I'll go ahead and distribute it now. That's really x squared plus hx. That, my friends, is a bunch of algebra. Get common denominators. Combine fractions with like denominators. Divide a fraction by a fraction. Algebra heaven right there. Yay! Okay, and then there is a summary on the back that you can read through. Yes. Okay, any questions before I turn this off? You think Jesse would have a question that we need to answer? What? Quizzing. Okay. All right, Jesse, you will be quizzed. All right, we're good. Okay, let me stop the recording.